Hello. Today we're going to talk about dimensional analysis. Dimensional analysis is a system we use in chemistry to do conversions. Today we're going to be doing simple conversions that you're familiar with, meters to millimeters, maybe feet to miles, and then we're going to do some conversions between metric and standard units, maybe inches to kilometers. We can do whatever. Dimensional analysis is a straightforward way that allows us to do those conversions. Now, some of you are great at conversions. You know how to do them your own way. And I get that. But what we're focusing on today is actually learning the method of dimensional analysis. So even if you can do a conversion another way, you got to do this. Because what we're learning right now is the method, not how to do conversions. We're just using conversions as a convenient way, a familiar way to teach you dimensional analysis. So the first thing that you're going to need to do is to make sure that you have copied slide 28 into your digital interactive notebook. Hopefully you did that at the beginning of class when I asked it. And the reason I'm having you copy this in is I've listed several common conversions that we're going to be using as we learn about dimensional analysis. So whenever we use the term dimensions, for example, I could ask you for the dimensions of this room. When we use the term dimensions, we're talking about what? What kind of information do I want if I ask you for the dimensions of this room? Well, most of you would realize that what I'm asking for is the length and the width and the height. So, for example, if we were talking about the dimensions of this classroom, you know, we have the handy floor tiles, which are each a foot. So we could count the tiles across and the tiles lengthwise to get our length by width, and then we could probably use a yardstick to get our height. And we would be talking about the feet, right? That would be our dimensions for this room. In dimensional analysis, the reason it's called dimensional analysis is we're focusing on those units. We're trying to convert from one set of units to another. Like I said, we're starting out with familiar units like yards and meters and inches and quarts and ounces, stuff like that. But ultimately, we're going to move to less familiar units like moles and atoms and particles and grams. So we start with stuff that we're familiar with so that we can progress to things that we're less familiar with once we're familiar with the method. So as I mentioned before, even if you can do a conversion a different way, you need to use this method for this activity. So in dimensional analysis, we set up ratios that allow us to focus on those units and cancel them out. What do I mean by that? Well, let's start by looking at a student's, let me make sure I have this sharing the right thing. I do. Let's start by looking at how many seconds a fellow student has been alive. For example, Quimby will be turning 15 on September 22nd. So we could calculate how many seconds that Quimby has been alive at her birth moment on that day using dimensional analysis. What do I mean? Well, first of all, we know that on September 22nd, Quimby will be 15 years old, right? So if we want to get closer to her age in seconds, what we can do is we can use ratios to get closer to the unit seconds. So stepping down from years, we can go to days. So I have two ratios that express going from years to days. I could say that 1 year is 365.25 days, or I could say that 365.25 days is 1 year. Now, you may wonder, why am I putting it in a ratio like this? Well, you remember when you're doing, when you're trying to add fractions, that you can get them to a common denominator as long as you're multiplying them by the equivalent of 1. For example, let's say that I was trying to add 2/3 and 4/5, right? Well, I can't add 2/3 to 4/5 directly, right? I want to get them to a least common multiple. Well, what's my least common multiple of 3 and 5? 15. So I can multiply 2/3 by 5/5 because 5/5 is equivalent to 1, right? So this would be 10/15. I could multiply 4/5 by 3/3 to get 12/15. And why can I do that? Well, this number and this number are really just 1, right? 5/5 and 3/3 are 1. So we can multiply anything by a version of 1 and maintain its character, its quantity. So even though these don't look like 1, they're the exact same amount of time. They're the equivalent to 1. So when I decide which of these to pick, I need to pick the one that will cause my unit to cancel out. What do I mean by that? Well, remember when you're multiplying fractions that anything that's in both the numerator on top and the denominator on bottom can be canceled out. For example, if I was multiplying 2/3 by 3/4 by 4/7, because I have a 3 in both the numerator and the denominator, I can cancel that. Because I have a 4 in both the numerator and the denominator, I can cancel that. So this would come out to be 2/7. You remember that math, right? Anything that's in both the numerator and the denominator can cancel. Well, in dimensional analysis, instead of focusing on the numbers to cancel, we're focusing on the units to cancel. So my 15 years is kind of understood to be a ratio with an understood 1 on the bottom. So if I multiply this, which one of these would allow my unit of years to be on top and on bottom? Well, this one, right? So I've brought my 1 year here and my 365.25 days here. So right now, if I was setting this up like a fraction to multiply, my unit of years is on top and on bottom, so it would cancel out. This will get easier, I promise. So we're trying, as we said, for Quimby, we're trying to get closer to the seconds that she's been alive. So what's our next step down after days? Hours, right? So on my next ratio, I know that there's 24 hours in 1 day. So what value, what unit do I need to go on bottom? Well, whatever was in the numerator of the prior ratio will need to be in the denominator of the next one to cancel. So I can go from days to hours. And what's that relationship? There's 24 hours in 1 day. Now you can see that day and day cancel. What's going to have to be on the bottom of my next ratio? Well, whatever is in my numerator of the prior. So here I'll have to have hours. What's my next step down from hours? Minutes. So what's that relationship? 1 hour is 60 minutes. Lastly, I want to get all the way back to seconds, right? I've gone from years to days, days to hours, hours to minutes. What's going to be at the bottom of my next ratio? Minutes. And I can go from minutes back to seconds. What's that relationship? Well, 1 minute is 60 seconds. Now, how do I actually problem solve this? First of all, I'm going to double check that I canceled all my units. Years on top, years on bottom, that cancels. Days on top, days on bottom, that canceled. Hours to hours, that canceled. Minutes to minutes. And what's on top of my last ratio should be what I'm solving for, which in this case, I was trying to figure out how many seconds Quimby had been alive. So now that we've got this set up, the way that we solve it is we multiply all of our numerators and divide by all our denominators. So literally it'll be 15 times 365.25 times 24 times 60 times 60. So when I put that in the calculator, you can see I get a mammoth number. I get 473,364,000 seconds. Notice that I didn't take the time to divide by ones, because when you divide by ones, does it change your number? No. So we now know that next week on the 22nd, Quimby will be 473,364,000 seconds old. That's a long time, Quimby. So now, I don't want you to presume that all dimensional analysis will look like this with numbers of 1 on the bottom. It doesn't always work that way. Let's say you had a weird friend, and at CCA that's not an impossible happening, right? And your weird friend had a baby brother, and they told you that their baby brother was 900,000 seconds old. Now that's kind of meaningless. Nobody talks about ages in seconds except for your weird friend. So if we're starting at seconds, we want to work back to at least days, right? To know how many days this baby's been alive. So our first step, remember, whatever unit we start with, that's going to go in the denominator, seconds. I'll write it out. So what's our first step up from seconds? Minutes, right? So what is that relationship? How many minutes are equal to how many seconds? Well, 1 minute is 60 seconds. So what needs to be on the bottom of our next ratio? Well, once again, whatever's on top comes down to the denominator. So 1 minute, and I can get closer now to, what's my next step up? Hours. And once again, I want to ask myself, what's that relationship? Well, 1 hour is 60 minutes. What's going to have to be on the bottom of my next ratio? Hours. Whatever's in the denominator, the numerator is going to come down to the denominator. And from hours, I can get to days. So what's that relationship? Well, 1 day is 24 hours. So I said I wanted to get to days. So let's double check that our units cancel. I've got seconds, which are kind of understood to be in the numerator and in the denominator. Minutes cancel, hours cancel, and I'm at days. Now, to put this one in the calculator, I'm going to do the same thing. I'm going to take my initial value, 900,000, oops. I'm going to multiply it by 1 times 1 times 1, and then divided by 60, divided by 60, divided by 24. And so what I find out is that this baby is 10.4 days old. Not very old at all. 900,000 seconds sounds like a lot, but it's not, is it? And that's how you do dimensional analysis. Now I've done it with something familiar, which is seconds. Let's try one more, just to kind of give you an idea of how it can be a little bit less familiar. Let's say that we are going from inches to kilometers, okay? Let's say I have 468,000 inches, and I want to know how many kilometers that is. So I'm always going to start with the value I'm provided in that unit, 468,000 inches. And how can I get closer to kilometers? Well, let's look back at our conversion sheet that I gave you for your digital interactive notebook over here. Okay, let me get this a little smaller so we have it handy. Scoot this over. So you can see that these are all these different conversions. So how can I get closer to kilometers? Well, the first value I come to that seems like it might be helpful, because at least it's getting me into metric, is that one. 2.56 centimeters equals 1 inch. So what unit's going to have to be in the denominator? Well, the one I start with, inches. And then I can go to centimeters. So what's the relationship between inches and centimeters? Well, according to this, 1 inch is 2.56 centimeters. Okay, still not to kilometers, but how can I get closer to kilometers? So let's see if I can find something that takes me from centimeters closer to kilometers. And I do have something. Up here, you see that 100 centimeters is 1 meter. So I'm looking at my next ratio over here, and I'm gonna want what unit on bottom? Centimeters. I know you're thinking that. And we're gonna go to meters on top. And according to our conversion, 100 centimeters is 1 meter. And I'm not quite to where I need to be, right? Because I need to go all the way to kilometers. So now, what unit, which of these relationships is gonna help me out? Well, I'm gonna use this one right here. I can go from meters to kilometers. So how do I know which one's on top and on bottom? Well, whatever's on top is gonna move down, meters. And I can put kilometers on top. According to this sheet, that relationship is 1 kilometer is 1,000 meters. And now I'm ready to do my math. Now look at this one for a second before I do my math though, and tell me how it looks different. If you look at our first two, you'll notice that we had all ones on top in this one. And on our birthday one, we had all ones on the bottom. But on this one, you can see that we had a combination, right? Well, we're switching between units, like between systems. We're switching from standard to metric. So it's okay to have numbers that aren't one on in both your numerators and your denominators. Just make sure the relationships are correct. 1 inch is 2.56 centimeters. 1 meter is 100 centimeters. 1 kilometer is 1,000 meters. So when I put this in the calculator, once again, I'm going to start with my number, 468,000 times 2.56 times 1 times 1 divided by 1 divided by 100 divided by 1,000. Remember, you just multiply all your numerators and then divide by all your denominators. So that the number I get is, well, let's talk about sig figs here. I haven't talked about that yet. But how many significant figures are in this initial number? Well, these are trailing zeros with no decimal. So there's 3 sig figs, the 4, 6, and 8. So when I go to round my answer, I want to keep 3 sig figs. These ones and these values here in conversions are pretty much considered perfect numbers. So we're never going to that's one thing handy about dimensional analysis. It's almost always going to be your starting number that dictates how many you keep in your answer. So in this case, I have 11.9808 kilometers was my initial number. But when I round that to 3 sig figs, it'll be 12.0 kilometers. So let that come back to where you can see. So we're going to try some together, one more in class together. I just wanted to explain this without a mask so that it would be a little clearer. Hopefully this will help you if you come back to review it. But go back to sig figs and dimensional analysis worksheets, and you're going to go to the 3rd sheet, and we'll work the first couple on that together so you have examples. and then I'm going to let you try some on your own. So good luck with dimensional analysis, and I hope that this was helpful. Let me stop recording. Talk to you in class.